Okay, so let's do another example. So this would be example 3. And we're going to start with an isosceles, or not an isosceles, but an equilateral triangle. Okay, so let's do an equilateral triangle. So all 3 of these angles are 60 degrees. So I have the altitude here, which is also a bisector. So we have a 30 and 30, right? And so let's say the length of all of these is going to be 2, since it's equilateral. If I have this altitude here, then it's going to be also split this bottom into 1 and 1. Okay? So now I have a right triangle. I have a right triangle here, and so I need to find the altitude of this equilateral triangle. And so if I use the Pythagorean theorem, what do I get? I get 1 squared plus, well, we'll call this a, right? So 1 squared plus a squared equals 2 squared. And so in this case, I get a squared is equal to what? 4 minus 1. Well, this is just 1, so 4 minus 1, which equals 3, right? And then so a is going to equal the square root of 3. So now I've got my 3 sides. Now, how do I deal with 30 and 60 degrees, right? So now I've got all 3 sides, right? So now I can just use the relationships, right? The ratios for the 6 trigonometric functions to get the evaluations or the ratios for all 6 functions for 30 and also for 60. So if I do this, let's do 30. So sine 30 degrees, cosine 30, tangent 30, and then of course, oops, cosecant 30, secant 30, oops, and cotangent 30. Okay, and then let's do sine of 60, cosine of 60 degrees, and tangent of 60 degrees, and then cosecant 60 degrees, secant 60 degrees, and cotangent 60 degrees. Okay, so now all we have to do is just remember the ratios, right? So sine of 30, so here's 30, right? It's opposite over hypotenuse. Where's the hypotenuse? Right here. So opposite is 1 over 2. So if sine of 30 is going to be 1/2. Cosine of 30 is adjacent, right? So that's this altitude. So that's going to be adjacent over hypotenuse. That's going to be square root of 3 over 2. Okay. Tangent 30 is going to be opposite over adjacent. So it's going to be 1 over the square root of 3 or square root of 3 over 3, right? Because you have to rationalize it. Then what are we going to do? We're going to just take the reciprocals of these. So this is going to be the reciprocal of sine, so that's going to be 2. Secant is a reciprocal of cosine, so that's going to be 2 over the square root of 3, right? But that's going to be 2 root 3 over 3, okay? And then cotangent is a reciprocal of tangent, so that's going to be what? That's going to be 3 over root 3, but then that's going to have to be rationalize, so that's going to give us the square root of 3. Awesome. So now let's do 60 degrees. Okay, so 60 degrees. Now this is our reference angle, right? So now that's our theta. So now we're going to do opposite, which is going to be this. So opposite of our hypotenuse, square root of 3 over 2. And then we're going to do adjacent over hypotenuse. So that's going to be 1/2. And then opposite, right? Opposite over adjacent is going to be square root of 3 over 1, which is just the square root of 3. Okay? And then we're going to do the reciprocals, right? So now, again, cosecant is a reciprocal of sine, so that's going to be square root of 2 over the square root of 3. But again, we have to rationalize it, right? So 2 over the square root of 3 is going to equal 2 root 3 over 3. Okay? And then secant is a reciprocal of cosine, so that's going to be 2. And cotangent is a reciprocal of tangent, so that's going to be 1 over the square root of 3. But again, we have to rationalize it, so it's going to be root 3 over 3. Okay? Now, notice in this example and the last example that we did for 45 degrees, all of these correspond to one of the points on the unit circle. Okay? So you got the same things because remember, sine of 30 is y, right? Sine of theta is y. Cosine of theta is x. And so we've seen these before when we're using the unit circle. But again, this is again using the right triangle. So the right triangle approach is directly related to the unit circle, as you see. All right. Is there anything else I want to say before we go on? Oh, yes. Notice how sine of 30 degrees is the same as cosine of 1/2. Notice how cosine of 30 degrees is the same as sine of 60 degrees. And notice how tangent of 60 degrees is the same as cotangent of 30. And cosecant of 30 degrees is the same as secant of 60. Oh, and tangent of 30 is the same as the cotangent of 60. And of course, cosecant of 60 is the same as secant of 30. Okay, these are, notice that also each one of those that are the same, right? For example, cotangent 30 and tangent of 60. Notice that 60 and 30 are complementary angles. Okay, they always add up to 90, right? Okay. And it can be shown from the right triangle, the definitions that cofunctions of complementary angles are always equal. We're going to talk about that. Okay, so those are cofunctions, right? So cotangent and tangent, right, are cofunctions. And we'll talk about that next time.